In this example, we're going to be using the binomial series to obtain a Maclaurin series for this function f of x. A couple of things that I would like for you to notice is that k represents any real number. The radius of convergence is 1. And we also have the formula 1 plus x to the k power. Okay. So what we want to do first is somehow write 2 plus x as 1 plus something. So what we can do is we can write f of x. Let me write it down. F of x is going to be equal to x squared over, we're going to have the square root of 1 plus x over 2 times 2. So what we did there is factored out a 2 from that radical. But that 2 is still inside the radical, so we factored it out from the radicand. So we are going to take this 2 out, and that new function becomes x squared over the square root of 2 times the square root of 1 plus x over 2. Let me rewrite this one more time. We can say that the function f of x is equal to x squared over the square root of 2 times 1 plus x over 2 to the negative 1/2. So f of x can be written in this form. All right, one more thing. I want you to remember that the binomial series converges for absolute value of x less than 1. Absolute value of x, because that's what the formula gave us. So we can say that this will be convergent for, remember the formula said absolute value of x less than 1. But that's not what we have here. What is it that we have? We have x over 2. So we can say that this binomial series will converge for x values that are in absolute value less than 2 units away from the origin. So from here, you can say that the radius of convergence is equal to 2. So the radius of convergence is going to be equal to 2. And let's continue working with the formula. So we know what f of x is. So f of x, let me rewrite it. I have f of x is equal to x squared over radical 2 times 1 plus x over 2 to the negative 1/2. In terms of your binomial series, in terms of this formula, we can say that k, let me highlight it, we can say that k is equal to negative 1/2. So k is going to be equal to negative 1/2. So we can now rewrite this as x squared over radical 2 times sigma, as n goes from 0 to infinity. The parentheses k and n, we normally write it down as k, or pronounce it as k choose n, and then x to the nth power. But what is it that we have in terms of x? We have x over 2 to the nth power, right? Because your x is here. And then one more time, what is k for our problem? K for our problem is equal to a negative 1/2. What I would like for us to do right here is to expand this sigma. So we're going to have x squared over the square root of 2. And then I'm going to multiply times. Let's expand and see where that takes us. So it's going to be a negative 1/2, choose 0, x over 2 to the 0 power, plus a negative 1/2, choose 1, x over 2 to the first power, plus a negative 1/2, choose 2, x over 2 to the second power, plus negative 1/2, choose 3, x over 2 to the third power, and then the idea will continue. So let's say we have a negative 1/2, choose n, x over 2 to the nth power plus something else. What I would like to do next, so we're going to come back to this right here. But let's do a little bit of side work because we have a formula, but I want you to understand where that formula comes from. So I want us to understand how we get the value for negative 1/2, choose 0, for negative 1/2, choose 1, for negative 1/2, choose 2, negative 1/2, choose 3, and the idea here continues. So let's just do a quick review. Let's just do a quick review. In algebra, when we learned about combinations, we learned it in the form of n choose r. N choose r. And n choose r, the formula for that was n factorial over r factorial. And then we have n minus r factorial. So, for example, if we have, let's say, 8 choose 6, then that would be equal to 8 factorial over 6 factorial, and then we have 8 minus 6 factorial. And you can simplify this to be 8 factorial over 6 factorial, 2 factorial, and then again you can simplify a little bit more. For the purposes of what I want to do, I want to simplify it in the form of 8 times 7 times 6 factorial over 6 factorial, 2 factorial. And then the idea is that you can simplify the factorial there. For this problem, you can continue moving forward, but that's not what I want to do. What I would like for us to do is to look at each of these individual combinations. What is negative 1/2, choose 0? Well, according to the formula that I just talked about, that would be equal to negative 1/2 factorial over 0 factorial. And then we're going to have negative 1/2 minus 0 factorial. And this becomes negative 1/2 factorial over negative 1/2 factorial, which is equal to 1. This is consistent because the very first term in your binomial series is 1. Now, what is negative 1/2, choose 1? Negative 1/2, choose 1. Let me rewrite it. Negative 1/2, choose 1 is going to be equal to a negative 1/2 factorial, again the formula, over 1 factorial, negative 1/2 minus 1 factorial, which is equal to a negative 1/2 factorial over 1 factorial, a negative 3/2 factorial. And then remember, we can simplify a couple of things. This, the numerator, the negative 1/2 factorial, is equal to a negative 1/2 times a negative 3/2 factorial. Why? Because what we're doing is we're going from n to n minus 1 to n minus 2. And then we're going to have 1 factorial, and then times negative 3/2 factorial. And we know that these will simplify. So you are left with negative 1/2 over 1 factorial. Let's continue. Oh, and then negative 1/2 over 1 factorial is really equal to negative 1/2. This is for the second term, and again, it makes sense. Negative 1/2 is just k for our problem. We're going to do maybe 2 more, and we'll see where that takes us. Negative 1/2, choose 2. This is going to be a negative 1/2 factorial over 2 factorial, negative 1/2 minus 2 factorial, which becomes a negative 1/2 factorial over 2 factorial times a negative 5/2 factorial. And we can simplify this to be negative 1/2, negative 3/2, because remember we're subtracting 1, negative 5/2 factorial over 2 factorial, negative 5/2 factorial. And this right here can simplify, and we can say that that is equal to a negative 1/2 times a negative 3/2 over 2 factorial. We're going to do just one more. Negative 1/2, choose 3, which is equal to a negative 1/2 factorial over 3 factorial, negative 1/2 minus 3 factorial, which is equal to a negative 1/2 factorial over 3 factorial times negative 7/2 factorial, which is equal to a negative 1/2 times negative 3/2 times negative 5/2 times 7, that is negative 7/2 factorial over 3 factorial, negative 7/2 factorial. One more time, we can simplify the factorials, and you can see what your answer is. So this is going to be a negative 1/2, negative 3/2, negative 5/2 over 3 factorial. All right, so let's continue here. If you were to do this all the way up to, let's say, negative 1/2 choose n, your formula would be equal to a negative 1/2 factorial over n factorial, negative 1/2 minus n factorial. Well, that will be equal to a negative 1/2 factorial over n factorial. And then we can write it down as negative 1 minus 2n over 2 factorial. This would be a little difficult to simplify if we wanted to. So instead, what we're going to do is we're going to leave it as negative 1/2 minus n factorial. The numerator, when you expand it, you have a negative 1/2, negative 3 over 2, negative 5 over 2, and then the idea continues all the way up to negative 1/2 minus n plus 1, and then negative 1/2 minus n factorial over n factorial, negative 1/2 minus n factorial. Okay. So if we were to continue, we can simplify this negative 1/2 minus n factorial, and your answer will be equal to negative 1/2, negative 3 over 2, negative 5 over 2, all the way to, let's say, negative 1/2 minus n plus 1 over n factorial. We're going to use this information now to go back to the problem. Remember, we were working on this part right here. So if we go back and write the information that we just found, we're going to have x squared over radical 2. So let's go back. So f of x is equal to x squared over radical 2 times. Remember that negative 1/2 choose 0 was equal to 1. And then anything to the 0, or x over 2 to the 0 power is 1. So we're going to have 1 plus, sorry for going up and down. So 1 plus, now we're going to work with negative 1/2, choose 1. And negative 1/2 choose 1 was just equal to negative 1/2. So we're going to have a negative 1/2. And then x over 2 to the first power plus, we're going to go to negative 1/2 choose 2, and negative 1/2 choose 2 is equal to negative 1/2 times negative 3 over 2 over 2 factorial. So here we have 1 factorial over 2 factorial times x over 2 to the second power plus, and now one last time, we're going to go to negative 1/2 choose 3, and negative 1/2 choose 3 will give us a negative 1/2, negative 3 over 2, negative 5 over 2, over 3 factorial times x over 2 to the third power, and then the idea will continue. Let me write it down. So let's say plus, and then we're going to have a negative 1/2, negative 3 over 2, negative 7 or negative 5 first. Negative 7 over 2, and then you're going to continue up until negative 1/2 minus n plus 1 over n factorial x over 2 to the nth power. Let's simplify this part a little bit more. So again, f of x is going to be equal to, we're going to have x squared over radical 2 times 1. I want you to notice that our signs are alternating. And why are they alternating? This is going to be negative, positive, negative. Your next term will be positive. The term after that will be negative, and so forth. So I'm going to alternate the signs. We're going to put a minus 1 over 2 times x over 2. And then I'm going to put here over 1 factorial. Plus, we're going to have 1 times 3 over 2 squared. Where this is this part here. 1 times 3 in the numerator over 2 squared. Okay. And then we can put here over 2 factorial times x squared over 2 squared. We have plus, actually minus. We have minus 1 times 3 times 5 over 2 to the third power over 3 factorial. And then times x to the third power over 3 to the third power. And if we continue, what is it that we're going to have? So let's see here, plus, we're going to have negative 1 to some power. So let's keep it at n, negative 1 to the nth power, and I'll tell you why. When n is 1, you have a negative sign. When n is 2, you have a positive sign. When n is 3, then it's going to be negative. Okay? And that is consistent with negative 1 to the nth power. Then we're going to have just the numerators here, just the numerator. So it's going to be 1 times 3 times 5 times 7 times all the way to, let's work with this and just write the numerator. Negative 1/2 minus 2 over 2 plus, that is 2n over 2, plus 2 over 2. So we can say that this right here is going to be equal to, let's see here, we can say it's going to be negative, where is it? Negative 2n plus 1 over 2. But remember, the negative is already taken care of, right? It's somewhere over here. So we can say times all the way to 2n minus 1. And then we're going to have over 2 to the nth power, x to the nth over 2 to the nth. All right, so now let's continue. We're going to simplify this a little bit better. We're missing here our n factorial. We're going to simplify this a little bit better. The 1 times 3 times 5 over 2 to the third factorial divided by, so 1 times 3 times 5 over 2 to the third divided by 3 factorial is 1 times 3 times 5 over 2 to the third times 1 over 3 factorial. And that's why I'm able to write it down here. So we can go back and clean this up a little bit more. We're almost done. I know it's a long example. We're going to have x squared over radical 2. We're going to have 1 minus x over 2 squared times 1 factorial plus 1 times 3 times x squared over 2 squared times 2 factorial times 2 squared. I forgot the plus. So we're going to have, this was a plus, and then now it's going to be a minus. 1 times 3 times 5 times x to the third power over 2 to the third times 3 factorial. And then we have, that's not 2 and 2. 2 to the third power. And then we're going to put all the way to, let's say, 1 times 3 times 5 times 7. All the way to 2n minus 1 over 2 to the n times n factorial times x to the n over 2 to the n. I'm going to distribute the x squares and leave the radical outside. So we're going to have 1 over radical 2. And then we have x squared minus x cubed over 2 squared times 1 factorial plus 1 times 3 times x to the fourth over 2 to the fourth times 2 factorial minus 1 times 3 times 5 times x to the third, and it's actually x to the fifth because we're distributing that x squared. So x to the fifth over 2 to the sixth times 3 factorial. And then we're going to have plus we're going to have 1 times 3 times 5 all the way to 2n minus 1. And remember, we have that negative 1 to the nth power. Let me put it here so that we don't forget it. We're going to have 2 to the 2n, n factorial, x to the n plus 2. All right, so we're almost done. We're going to have, see, here we have 1 times 3 times 5 all the way to 2n minus 1. And then the idea is that it goes back. But here we have 1 times 3 times 5 and 1 times 3. We can think about this as 1 times 1, and we don't want to worry about a negative. We don't have like a negative number there. So what we're going to do is we're going to write it down as x squared over radical 2. Okay. Plus 1 over radical 2, which is really equal to 2 to the 1/2 times sigma, as n goes from some number to infinity. And let's start thinking about the formulas. We know we're going to be having alternating signs. So we're going to have alternating signs. And then we're also going to have a fraction. We're going to have n factorial if we begin at 1. So if n is 1, negative 1 to the first power will give you a negative first term. So we can put a negative 1 to the nth power. When n is equal to 1, let's talk about the powers now. When n is 1, the power is 2. When n is 2, the power is 4. When n is 3, the power is 6. When n is n, the power is 2n. So this will be 2 to the 2n power. We're going to have x to the n plus 2. You can see that in your nth term. And you can check, we're starting here. So when n is 1, your power is 3. When n is 2, your power is 4. When n is 3, your power is 5, and so forth. And then we have the coefficients. So in the numerator. So then you're going to have 1 times 3 times 5 times all the way to 2n minus 1. So your final answer is x squared over radical 2 plus sigma as n goes from 1 to infinity, negative 1 to the nth power, 1 times 3 times 5 times all the way to 2n minus 1 over 2 to the 2n times 2 to the 1/2, which is really 2 to the 2n plus 1/2. Times n factorial. And then we can say times x to the n plus 2. This right here is your function. This right here is your function as a power series. And remember, we need to find the radius of convergence. And the radius of convergence, we said it was 2. From way up here. Do you remember? We did a lot. So our radius of convergence was equal to 2.